Hi, my name is Andy Lewis with Innovative-IDM, and today I'm here to talk to you a little bit about some guidelines whenever speccing in or picking out an industrial motor. It's really not as hard as you might think. It's pretty simple, to tell you the truth, but there are a couple things you need to pay attention to. One, sizing. Whenever we're talking about mounting size, or we're talking about voltage, or we're talking about current, we need to make sure that if it's mounting, the holes are going to match up. All right, so you need to make sure that if it's a 494T mount, that what you get is capable of handling that mount. Second off, current and voltage, as long as the application is not changing, need to be the same as the previous motor. All right, if you're unsure of that information, I would suggest that you take a look at the force requirements and other requirements from the application before you spec in that motor. Take a look at torque curves, make sure that you're providing enough information so that you can pick out the right size motor. Second off is environment. Is it in a harsh environment? Are there pieces of rock and dust and dirt falling on it? Or is it inside? Is it just general purpose to run a fan 24/7, all day, every day? Another idea is to take a look at whether it's inverter duty or general purpose. And whenever we say inverter duty, this type of motor is made for a high duty cycle environment. Okay, so it's constantly speeding up, slowing down, speeding up, slowing down, all from an inverter or a VFD. Next, really there's a couple different ways of controlling a motor. You can do it across the line, meaning that the motor is basically just hooked up 3-phase or 1-phase, however it is, to a circuit or a disconnect. Otherwise, you can use a VFD, variable frequency drive, and use volts-hertz control. You can do open loop vector, or you can do closed loop vector. The main thing you need to know here is that if you're going to be going with closed loop vector for the most control out of that motor, you're going to need an encoder or tach for a DC motor to actually make that happen. So don't overlook that, and make sure that the mounting bracket on the back side is going to fit the encoder that you use. And finally, speed range. What speed are you working at? Do you need a gearbox? Do you need some type of rack and pinion? How do you plan on driving the end product? All questions that are very important, but if you do it correctly, it shouldn't be that difficult. For more information, go to innovativeidm.com, and remember, Innovative-IDM is the home of the legendary customer experience.